Hi everyone, and welcome to our video on polar roses. So polar roses have the form r equals a constant, so a is a constant, times the trig function sine or cosine with a special angle, so in theta, where n is a whole number greater than 1, so like 2, 3, 4, 5, whatever. And we get the shapes of these graphs based on the value of n. So if n is odd, we will have a rose, so they call them polar roses. There would be a flower, maybe not really a rose, but anyway. So if we would still say rose with n petals. So if n is odd, we know we're going to have n petals. If n is even, we're going to double it for the number of petals, 2 n petals. And then after that, we use the properties of symmetry and rotational symmetry to help us with the rest of the graph. All right, so to graph these problems, let's first break it down. So let's see what all this means up there. So in this first problem, we want to know the number of petals. Well, we look at the n. So the n is 3. That's odd. So that means in our problem, we have that exact number of petals. We'll have 3 petals. So 3 petals of a rose. Okay, and then the second step in these problems is to maximize the trig function. All right, so to maximize the trig function, I'll just say it like that, maximize trig function, which means we just want to set the trig function angle. So cosine, so in this problem, cosine of an angle should be 1. Or if it is sine, sine of whatever the angle is should be 1. And we know on the unit circle that to get 1 out of cosine, this angle should equal 0. And for sine, the angle should be pi halves. Okay, so because cosine of 0 is 1, sine of pi halves is also 1. So we're just trying to figure out that. So in our problem, they're saying, well, and cosine's a little nicer, but in our problem, they're saying, oh, the angle that was given is 3 theta. To solve for theta, we just divide by 3, and we would get theta is 0. So this is the angle that maximizes our trig function, our rows. Okay, so let's start our sketch. So all this will start to come together. So here's our 0, pi halves, pi, 3 pi halves, and then 2 pi. So what this maximizing does, so when our theta is 0, it's saying we should go with our r equaling 4, the constant amount, and go toward that angle a length of 4. So we've got 1, 2, 3, 4. So here's angle 0. And then go toward it a length of 4, like that. There's my point. And then from here, we know that's where 1 petal will be. Okay, so we draw this loop type shape the best we can. Okay, so this is the first petal. And then now we're going to use all of the symmetry to help us with the rest. Okay, so our third step, so I just wanted to get the petal drawn first. Our third step is to find the other petals. So let's mark this. This is the angle of first petal. And then now our third step is to find angles of other petals. Well, to do that, all we do, we know the full graph goes around 2 pi, an angle of 2 pi. So all we do is take 2 pi and divide by the number of petals. Okay, so in our problem, it would be 2 pi divided by 3. So it's every 2 pi divided by 3 after the first petal angle. Okay, so this gives us the others. Okay, so that means for our scratch works, so I'm going to put number 3 scratch work right here. Our first angle was 0. Every 2 pi thirds after would mean you just add 2 pi thirds. So that means at 2 pi thirds, I should have another petal. Okay, so I'm going to do a dashed line. So here's where 2 pi thirds the angle is, or at least about. Okay, and then let's get our other petal ready. So 2 pi thirds plus another 2 pi thirds would be 4 pi thirds. Okay, so that would be somewhere like that. So here's our 4 pi thirds angle. And then notice if I do add another 2 pi thirds to that answer, 4 pi thirds plus another 2 pi thirds, I would be back to 2 pi. So 6 pi thirds is 2 pi, which means I already have that petal traced and we would be done with the problem. Okay, so all we have to do now is use our dashed line and count a length of 4. Okay, so I'm trying to measure the same length, 1, 2, 3, 4. I think that's about right. And then let's do it 1, 2, 3, 4. I hope that's about right. And then we make our petal the same way that we just did for the first one. Okay, so something like that. And something like that. Okay, so and it's not the most beautiful thing. And if you type this in Desmos exactly as shown with r equals 4 cosine of 3 theta, you'll get a much prettier picture, but it would be this. Okay, so this is the breakdown of how we can find these roses. I would say more like a daisy or some other flower, but they do call them roses, whatever. All right, so let's try one more here. Okay, so this is our process though. 1, 2, 3. Okay, so let me just give myself the graph labeled with the major axes angles. And then now let's get our steps going. So the first step is to know the number of roses. So in this problem, and let me put the parentheses there, n is 4. Okay, so this is even, so that means we should double it. So 2 times 4 is 8. There should be 8 petals. Okay, so this one's going to take a little bit more drawing of petals. Step 2, let's maximize the trig function. So remember, sine of some angle should equal 1. Our angle in this problem is 4 theta. Oops, sorry. We know the angle that they're talking about is pi halves. But in our scenario, it's 4 pi, or 4 theta, 4 theta, there we go. 4 theta is equaling pi halves. That's how we can maximize the trig function. And then while we should multiply by a quarter to get theta is equal to pi eighths. Okay, so again, this is where the first petal goes. Okay, and let's take care of step 3 and then we'll start tracing everything. Step 3, we want to find where the other petals are going to be. Well, that's taking 2 pi and dividing it by the number of petals, which is 8. So that's pi quarters. So every pi quarters after pi eighths is how we'll find the other petals. Okay, so that means let's get our scratch work going. Okay, so we're starting at pi eighths as the first petal, and then we're going to add pi quarters to it. Well, it looks like we need a common denominator. Pi eighths plus 2 pi eighths would be 3 pi eighths. Okay, so this is where the second petal is. And then let's just keep it going. Okay, so 3 pi eighths. The pi quarters, let's just make it 2 pi eighths right away because we need that common denominator. And we'll get 5 pi eighths. So there's where the third petal is. And then we might even be able to see a pattern here without doing the addition. Notice it's our odd pi over 8. So the next one, so I'm going to start just listing it out, would be 7 pi eighths. And then 9 pi eighths. So this is the 4th, 5th. Let's set these up. 6th, 7th, and then the 8th. So another odd pi up in the numerator. The next one is 11 pi eighths. Then we have 13 pi eighths, 15 pi eighths. If I did say, if I kept going, so the 9th would be, 17 pi eighths, the next odd. But that would be coterminal with pi eighths. Okay, so that means that's a good sign. We're back to the very first petal. So that gives us the eighth. There is not a ninth. Then the ninth is the same as the first, whatever. All right, so now all I'm doing is marking all of my angles. So pi eighths. So here I'm going to do it like this. So here's where pi quarters is. I know I don't have any pi quarters, but it might help with graphing these problems. Because they're all pi eighths. I know pi eighths is half of pi quarters. All right, so let's make that a little thicker then. So my pi quarters is here, or my pi eighths is here. 3 pi eighths would be in between pi halves and pi quarters. So here. So here's 3 pi eighths. And then 5 pi eighths is in between. And then 7 pi eighths also in between. And then just keep it going. 9 pi eighths is still in between. And then we've got 11 pi eighths. And then 13 pi eighths. And then finally 15 pi eighths. Okay, so there's the setup for all of it. And then I'm going to change it to blue. So the last thing that we need now to finish this graph is to look at our 5 right here. So it's saying I should go a length of 5. So 1, 2, 3, 4, 5. And then make my petal from there. There we go. And then I should do it to all of them. I'm going to say here's where about 5 is. Okay, so hopefully that's pretty accurate. So they should all be the same length of petal. And then my next one I'm going to say is about here. Okay, and then the next one maybe about here. And then 4 more, and it should have nice symmetry to it. There we go. Mine's not looking the best, but it's as good as we can get on a computer with the tools that I have. And then the last one. Okay, so something like that. Again, if you want to see a prettier one, plug that into Desmos as it's shown right there, and it will give you a nice polar rose, as they call it. Okay, but that's it there. So it's the same 3 steps every time. It's just if there's more petals, it's going to take longer. So the odd cases are a little better because there's going to be less. So even you double it, but then afterwards it's a similar process. I think sine is also a little worse than cosine, but that's it. There's our full length process of graphing polar roses. Okay, so that's that. If you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.